Hi everyone, welcome back to Lulumath. This video is on like terms. I would just want you to know that if you'd like a copy of these notes, they are available at lulumath.com. But before we actually get into like terms, we have to figure out what makes like terms like terms. So let's look at examples and non-examples of like terms. So if you see here, an example of like terms would be 6x and 11x. A non-example of like terms would be 6x and 11y. So if you notice, x and x work here, but here we've got x and then we have y. So this doesn't work. They're not like each other. You can't put them together. Here's another example of like terms. We've got 3x squared and x squared. So x squared and x squared, they both have x squareds in it, as opposed to over here, we have an x squared and just simply an x. In the first set of examples and non-examples, they had the same variable, and here they had different variables. But in our second example, they both have x's in them. What's different is that they have different exponents. Let's look at another example. Here we have 10x squared y and negative 6x squared y versus 10x squared y and negative 6xy squared. So what's the deal with this one? They both have x's and y's in them, and they both have squareds in them. Over here we have x squared y and x squared y. The squared is on the x and the y has an exponent of 1. Over here, however, the x is being raised to the power of 2 here, but the x is only being raised to the power of 1 here. The y is being raised to the power of 1 in the first term, but it's being raised to the power of 2 in the second term. So although they appear to have the same exponents, the exponents are not on the same variables. And in our last example, we have negative 8a squared bc to the power of 3 and 15a squared bc to the power of 3. But over here, we have negative 8a squared bc to the power of 3 and then abc to the power of 6. So if you see, we have a to the power of 2, a to the power of 2, b to the power of 1, b to the power of 1, c to the power of 3, c to the power of 3. But in this example on the right side, some people might say, oh, we've got a power of 2, a power of 1, a power of 3. 2 plus 1 plus 3 is 6, so I can just say ABC to the power of 6 and they'll be like terms. But that's not true. That doesn't work. So based on that, what are like terms? Well, like terms must have the same variable with the same power. So here we've got x to the power of 1, x to the power of 1, x to the power of 2, x to the power of 2, x to the power of 2, y to the power of 1, x to the power of 2, y to the power of 1, a to the power of 2, b to the power of 1, c to the power of 3, a to the power of 2, b to the power of 1, c to the power of 3. They all have the exact same variables with the same power on each variable. So now if we have like terms, we can collect them or we can combine them. And depending on your region, some places say we collect them, some places say we combine them. They mean the same thing. So if you see here, we've got 12x minus 9 plus 8 minus x. Well, 12x is not like negative 9 because there's no x on it. It's not like 8 because there's no x on it, but it is like this negative x. So I can put them together. So this is just saying I've got 12 x's and I'm taking away 1x. So 12x minus 1x is 11x. Now, if you see here, this is a constant and this is a constant. They don't have variables at all, so that makes them like each other. So when I add negative 9 and 8 together, I end up getting minus 1. And this is my final answer because I can't collect any like terms more than this. There's nothing left that's in common. Okay, in our next example, we're asked to collect or combine like terms again. So here we have 5x squared, so we've got an x to the power of 2, and this 3x is not like the 5x squared because this is x to the power of 1, but this minus x squared is like it because it has the same variable and the same exponent. So I can say that those go together. So if I have 5x squareds, and I take away 1x squared, then I have 4x squareds left over. Now, a common mistake that people will make is they'll say 5x squared minus x squared, the x squareds cancel out, and then we just have a 5 left over. So this is wrong. We don't want to do this. And the reason why it's 4x squared is because 5x squared just means x squared plus x squared plus x squared plus x squared plus x squared. And then we're going to copy down this minus x squared, and these cancel each other out. So altogether, I have 4x squareds left over. Then I can see I have a 3x here, but nothing else is like 3x because all that's left over is a 2 and it doesn't have an x on it. So I can just copy down this plus 3x. And then there's just a 2 left over. Again, nothing else is like it, so I can just copy down this 2. And this right here is my final answer. It's completely simplified. All right, in our last example, we're asked to collect or combine like terms again. So looking here, I have 3.2a, and looking at the rest of my expression, 7.2b, negative 12.1, negative 9.5b, plus 4, none of them have an a on it, so there's nothing like 3.2a, so I can just copy that down. Now I have 7.5b here. Negative 12.1 does not have a b on it, so that's not like it. But negative 9.5b does have a b, so those two are like terms. So 7.5, and it's a positive 7.5. So 7.5 and negative 9.5, when I put them together, gives me negative 2. So I can just say that this is negative 2b. And then lastly, I have negative 12.1 and positive 4. They're my constants. They don't have any variables. So when I put those together, I end up getting negative 8.1. And this is my final answer. That's it for this video. If you have any questions, please let me know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye!